Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will try and explain how to perform a hypothesis test on a binomial distribution. You perform this test to identify whether the given probability of the distribution of binomial is true or not. So, first of all, let's try and identify these steps that we have to go through, and then we will try and relate that with the example. When performing a hypothesis test, the first thing that you must do is to identify your null and alternate hypothesis. So there would be a given probability of the binomial distribution, and you have to check whether that probability has changed in terms of the way that maybe the probability has increased, maybe the probability has decreased, or it has just changed. So you write down the null and alternate hypothesis. You write down null hypothesis as probabilities equal to whatever was the initial established value of the probability, which is P is equal to P naught. And then you write down your alternate hypothesis based on whether it's increasing, decreasing, or it is changing. So if there's a decrease in probability, then you would say probability is less than P naught. P naught is the value probability that you would be testing it on. If you are looking for an increase in probability, you would write P is greater than P naught. Or if you're looking for a change in probability, that is, you're not sure whether it has increased or decreased, you will write P is not equal to P naught. So out of these three, you will have to only write down one, which will determine what type of test it is. So if you're looking for a decrease in probability, that will be called one-tail lower tail test. And in such a case, the critical region is going to lie at the lower tail of the distribution. If you're looking for an increase in probability, then it will be a one-tail upper tail test, and your critical region should lie on the upper tail of the distribution. Whereas if you're looking for a change in probability, then it will be a two-tail test, and hence your critical region would be equally divided both on the lower tail and the upper tail. For such a test, you will always be given a significance level. And significance level is basically the probability of the critical region, that is the probability of alternate hypothesis. So if you are given the significance level of alpha percent, that means for a lower tail test, the lower tail must have a probability of alpha percent. For an upper tail, the upper tail must have a probability of alpha percent. But if it's a two-tail test, then alpha gets divided equally on the two tails. So there will be an alpha by 2% at the lower tail and alpha by 2% at the upper tail. For instance, if you know the significance level is 5%, for one tail lower tail test, your lower tail probability has to be 5%, and that is where your critical region would lie. Or if it is a one tail upper tail test, then your critical region would be upper tail 5% probability. But for two tail test, it will be 2.5% on both tails. So after identifying the null and the alternate hypothesis, the next thing you must do is write down the distribution. For every hypothesis test, your way forward is with the assumption of null hypothesis to be true. So with the probability to be P naught, assuming null hypothesis to be true, you will write down the distribution of the test statistic. So you will write X follows a binomial distribution, N is number of trials, and P is the probability of success, which you will always pick from the null hypothesis. And once you have written down the distribution of the test statistic, you have to now identify the critical region. You already know the probability of the tail, so you will keep on sort of adding the probabilities and you will see where it exceeds alpha percent. So if it's like you are getting a cumulative probability of like 0, 1, 2, 3, 4, you just keep on adding these probabilities. And whenever it crosses alpha percent, that means that this is where you would stop. So let's say you're doing a one tail lower tail test and your n is 10 and your alpha is 5%. So you find the probability of x is less than equal to 0, then you will find the probability of x is less than equal to 1 by summing up the probability of 0 and 1. And then you will find out the probability of x is less than equal to 2 and so on and so forth. And you keep on doing that till you exceed 5%. So let's say this is coming out to be 0.045 and let's say this is coming out to be 0.053. So that means that it crosses 5% between 1 and 2. So your critical region lies between 1 and 2. So that means your critical region is going to be 1 or less than 1. Remember, it is a discrete probability distribution, and because of that, obviously it can't be a decimal value. So if you know it lies between any two values, then you would know that what integer value you have to take for the critical region. So if it crosses between 3 and 4, then your critical region is going to be less than equal to 3 and so on and so forth. Similarly, if you know that your critical region lies at the upper tail, then you will first calculate the probability of 10, then 9 plus 10, then 8 plus 10, and you'll see where it exceeds 5%. Let's say it exceeds 5% between 7 and 8. So you would know that 8 or more than 8 is going to be part of your critical region. So you have to, next thing that you have to do is to identify the critical region based on your significance level. And once you have identified your critical region based on the significance level, after identifying the critical region, you will have a particular test value that you are testing it on, and you will see where the test value lies. If the test value lies in the critical region, then H1, that is alternate hypothesis, would be accepted. But if your test value lies in non-critical region, that is H0, will be accepted. So based on where the test value lies, you will identify whether you're going to accept H0 or H1. And after identifying that, you will write down a concluding statement with respect to the situation. Let's have a look at one example. So the question says, Sid says he has psychic powers and he can read people's thoughts. To test this claim, a volunteer from the audience sits on the stage while Sid sits in the separate room off stage. The volunteer chooses a card from a well-shuffled pack and concentrates on the card for 5 seconds. At the same time, Sid writes down the suit of the card, either hearts, diamonds, spades, or clubs. The card is replaced in the pack is shuffled again, and then another card is drawn. The procedure is repeated until 20 cards have been drawn. And the result is that Sid has given 7 correct answers. So we have to test Sid's claim at 5% significance level, and we will also have to find out the critical region for that. So, we can do it in the opposite order. Let's first find out the critical region, and that way we will be very quickly able to find out the Sid's claim. Since you are picking a card from a well-shuffled pack of cards, so the probability of selecting a particular suit of card is going to be 1 over 4 or 0.25, and he does that 20 times. So if he does not have psychic powers, then his probability of guessing the right card is going to be 0.25. So if Sid has psychic powers, then he will be able to guess the suit of the card with the probability greater than 0.25. So H0 is P equals 0.25, and H1, him having psychic powers, the probability is going to be exceeding 0.25. So you write down the distribution with the assumption of null hypothesis to be true. He picked 20 cards, so 20 cards and probability is going to be 0.25. Since you're looking to find out an increase in probability, you must have already identified that it is a one-tail upper tail test. Since it is a one-tail upper tail test, so your critical region must lie at the upper tail. Since you are performing the test at the 5% significance level, so the probability of the critical region is going to be 5%. You find the cumulative probability of values greater than a particular number and see where it exceeds 5%. So we will find out the probability of x is equal to 20 by using the formula of probability distribution of binomial, which is probability of x equals r equals NCR q power n minus r and p power r. So we use that formula to find out the probability of x is equal to 20, and then we will find out the probability, because this is not exceeding 5%, this is nowhere near 5%. So I'm going to now calculate the probability of 19 and 20. So I'll just calculate the probability of 19 and add the previous probability onto that, and this is also something which is very, very far away from 5%. Then I will calculate probability of x is greater than equal to 18, and that comes out to be also very smaller than 5%. How I find the probability of x is greater than equal to 18 is by calculating the probability of x is equal to 18 and add the previous cumulative probability onto that. So I keep on doing that to find the probability of x is greater than equal to 17. I'll find the probability of x is equal to 17 and just add the previous probability onto that. So I keep on doing that. These are the cumulative sums. Like for 16, it's 16 plus the previous sum. So I keep on adding these probabilities, and I will only stop at the point where I cross the 5% mark. So you see between 9 and 8 is where I cross the 5% mark. This is 4.10% and this is 10%. So that means the critical region crosses between 9 and 10. So I would know that your critical region is going to be 10 or greater than 10 because it crosses between 9 and 10. So once I've identified, I will look at the number of correct cards that Sid found out, and that came out to be 7. So the test value is 7. Your critical region is 10 or more. So that means the test value lies outside the critical region, and hence H1 is going to be rejected and H0 is going to be accepted. That means that Sid has no psychic powers. So that's how you will perform the hypothesis test on a binomial distribution. Let's have a look at another example, and this is one from the past paper question where it says Arvind uses an ordinary fair six-sided die to play a game. He believes that he has a system to predict the score when the die is thrown. Before each throw of the die, he writes down what he thinks the score will be. So he's throwing a die and he will be just guessing that probably it's going to be 6 or 5 or 4. So he's performing a test on that. So he's guessing the number on the dice before throwing, and it's been found out that out of 15 throws, Arvind has been correct 5 times, and we have to test his claim at 10% significance level. Since a die has 6 faces, so probability of selecting any particular face is going to be probability is equal to 1 over 6. So if he does not have any system to figure this out, then his probability should be something around 1 over 6. But if there is a system by which he is able to figure this out, then his probability should exceed 1 over 6. This again is an example of one tail upper tail test. So I know my critical region is going to be lying at the upper tail. I can do the cumulative probabilities and see where the 10% exceeds, and I can find out the critical region. But what I can do is that I can just also directly find out the probability of greater than equal to 5, because that is my test value. And once I find out the probability of greater than equal to 5, and that comes out to be 8.98%. So if greater than equal to 5 is 8.98%, so that means it lies within the 10% of the upper tail. So I will find out the probability of greater than equal to 5 by doing 1 minus probability of 0, 1, 2, 3, 4. And once I've done that, and it comes out to be 8.98, and I figured out that 8.98 is smaller than 10%, so this should be lying within the 10%. So that means the test value is part of the critical region. So that means its probability is greater than 1 over 6, and over here the H1 is going to be accepted. Unlike the previous question where H0 was accepted, here H1 is going to be accepted. That is, he can predict scores. Let's have a look at one more final example. A drugs company produced a new pain-relieving drug new pain relieving drug for migraine sufferers, and it advertisement stated that the drug had a 90% success rate. A doctor doubted whether the drug would be as successful as the company claimed. She prescribed the drug for 15 of her patients, and after 6 months, 11 of these patients said that the drug had relieved their migraine symptoms. So we have to test the company's claim at the 5% level of significance. So if you know if the company's claim is correct, then the probability is going to be 0.9. But the doctor feels or tests whether it's going to be less than 0.9 or not. So the alternate hypothesis would be probability is less than 0.9. So this is an example of one tail, lower tail test, and your critical region should lie at the lower tail. So with assumption of null hypothesis to be true, and since it was prescribed to 15 patients, we write down the distribution of test statistic as binomial with n being 15 and probability being 0.9. Then to test the claim, I know it's a one tail lower tail test, so I'm gonna get a cumulative probability of that value between which it exceeds 5%. So I calculate probability of 0, then I calculate probability of 0 and 1 by adding probability of 1 to the previous probability. And then I add probability of 2 to the previous probability. Then I add probability of 3 to the previous probability. And I just keep on doing that till I see I exceed 5%. So the 5% is exceeded between 10 and 11. So you know that your critical region lies between 10 and 11. So that means anything 10 or less than 10 is going to be part of the critical region acceptance, whereas anything 11 or more than 11 is going to be non-critical region. Since it relieved 11 of these patients, which was lying outside the critical region, so that means H naught is going to be accepted and the probability is 0.9 and the company's claim is correct. I hope guys this was helpful towards knowing how to perform the hypothesis test on the binomial distribution. Thank you. Please subscribe my channel and like this video.